Yeah, twitchy, fading, the bone went missing here. It's aberration as an omen.
Hi, my name is Min Jae Kim, and I will be doing question 4, part A. Because the satellites are in an orbit around the Earth, the centripetal force is a gravitational force in this problem. Therefore, the centripetal force equals the gravitational force. The centripetal force is mv0 squared over 2re, where re is the radius of the Earth. And the gravitational force is gme times mass of the satellite over 2re squared. Now, when we make these two equal each other, the mass of the satellites and the radius cancels out, leaving v0 squared equals gme over 2re. Now, moving the root over gives us the orbital speed root gme over 2re.
So part B asks us to assume the satellites collide head-on and stick together. This tells us that this collision is perfectly inelastic. And furthermore, we're going to use conservation of angular momentum to solve for the final velocity of the combined mass after the collision. So since we can assume that these are point masses, we can use angular momentum of each individual satellite is equal to mvr, where the masses are the m is the masses of the individual satellites. The r is the distance that they are from the Earth, which in this case is 2 times the radius of the Earth. And on the left-hand side of the equation here, you can start to see how this describes the situation. So we start with v0, 3m, 2re, and v0. Since it is traveling, we set that one as a positive direction, and we subtract the one going in the opposite direction, since we can set that one as a negative velocity. So then the left-hand side becomes 3m times 2 radius of the Earth times the initial velocity minus the 1m times the same distance, 2re, times the v0, since it's traveling at the same speed, just different directions. And then on the right-hand side, you can kind of see how this illustrates the combined mass. You would then add the masses together to get 4m. It's at the same radius, so 2 times the radius of the Earth. And then the velocity final is what we're trying to find, so that's tacked on the end there as part of the MVR. And you can cancel out the 2 REs, the M's also as well, you can group them out and cancel. So at the end, after simplifying further, you get 2 times V0 is equal to 4 times the final velocity, and then therefore you can isolate for final velocity to get that the final velocity is equal to 1/2 of the initial velocity.
So in part 4C, we're asked to find the total mechanical energy of the system after the collision. So the mechanical energy is found as the sum of the kinetic and the potential energy. Potential energy in this case refers to the gravitational potential energy, and kinetic energy will be found as 1/2 mv squared. And in this case, m is basically equal to the total combined masses, which is 3m plus m, which is 4m. So you get 1/2 times 4m times v final squared. And then for the gravitational potential energy, the formula is negative g big M little m over r. In this case, big M represents the mass of the Earth, little m is the combined mass of the satellites, and r represents the orbiting radius, which is 2re. And the next step, we further simplify this by taking what we got in part B, where we get v final is equal to 1/2 v initial, and we plug that in, substituting v final for that derivation, and our final answer comes out to 1/2 v initial squared minus 2g mass of the Earth times little mass over the radius. We'll further simplify this and solve for v orbital in terms of g, m, and r.
So I'm going to reiterate that this is a perfectly inelastic collision, meaning that the particles stick together, so we're going to have to consider the total mass when calculating the kinetic energy and u sub g. And so based off of what Akshat already did, we now have the expression 1/2 m v0 squared minus the expression for u sub g. So now all we need to do is sub in a value for v0 in order to get the expression in terms of g, m, m sub e, and r sub e as the question asked. So to do that, all we need to do is substitute the value for the v orbital, since that is the same as v0, and then just do a few quick calculations in order to get negative 7 g m sub e m over 4 times r sub e.